On this slide, what I did was this is a technical review or a verification checklist. This is actually 2 pages. I just put them all on one slide here, right? Here's a verification checklist that we developed for one of our customers. Now, this is nuclear grade. Don't let this thing freak you out. But what I wanted to do was kind of show you an example of the types of questions that need to be considered when someone says you're doing a technical review, right? So not only what I'm seeing is that, okay, well, maybe, I don't know, maybe Kevin Hughes is on the list for, on the software list for, I'm going to go ahead and send this over for a review for Kevin. Kevin's using his own experience and knowledge and many years that he's done things. And he's coming up with his own criteria of what good looks like. And then he's signing off on something. But when you look at these checklists, so let's read through this just a little bit, right? So when you look at it, you say, all right, well, do the procedure instructions provide control of the work activity throughout the procedure? Okay, so what they're trying to say is this thing constantly, step-by-step process that you're always have controls in place as the work is being done, right? If special tools or equipment this is a good one. So if special tools or equipment or intrusive test equipment are used on a system in service, are adequate instructions provided to prevent failure of the tool or the equipment from affecting system operation? Where did that question came from? From when you get instrument control technicians that are doing some troubleshooting and they connect a digital voltmeter on some terminals and then they ground the system out, the component fails and trips the unit off. Why is that? Because either they didn't connect the tools right or there was something wrong with the test equipment. But is there a possibility that the test equipment that you're going to attach to the system that's in service and operating while you're 100% power doing things, is there a chance that if that thing was the fault that you're going to have a bad day, right? I mean, is there nothing we can do about that? Or is there something that we need to take in consideration for that, right? Does a procedure include controls to prevent problems with other channels or divisions that could affect plant operation if needed? So what they're saying is that in the nukes in particular, lots of times they have 4 channels of identical safety equipment. But there are times electrically where you're going to be very careful because you could end up connecting something that now you're into 2 of those systems, 2 of those channels, and you may not even be aware that you're doing it, right? And now all of a sudden you cause a problem there, right? So this is so what I'm trying to get at is there's all kinds of different questions in here. Are instructions for the user to make notifications to take follow-up actions where needed? Are there hold points or inspection points that may be added? Are you satisfied that the procedure revision does not challenge safety, industrial safety, and things of that nature? Sorry. So then you go in here and you say, okay, will the proposed new or revised procedure alter the ability of the operator to assess or control the nuclear safety status of the plant, right? So that's another way of saying it is like, okay, could there be a loss of indication, right? So let's say that they're doing some testing and the procedure's doing this stuff, but it removes this pressure gauge, this pressure indicator, and now it's not going to be reliable because they're retesting it. And it's like, but if they had an accident, they need to rely on that gauge, to be able to do that. But now what happens if they're working on it and now it's not available? Do I need to provide some alternative method to monitor the safety of what's going on through another process? You understand what I'm getting at? So, so what I'm trying to get at is that, is there increase the potential for a plant trip? You guys that are in the refining petrochem, I'm sure you can come up with your own variances of these things. But notice in here that this is a verification review. It's looking at the technical adequacy of the document that you wrote. Notice down here on the last page of this review checklist, it says, hey, look, the technical reviewer is knowledgeable of the subject area, right? It also says that don't worry about number 2. Checklist questions are answered to the best of the reviewer's knowledge. Questions and procedure errors when identified are sent to the procedure writer. So and then what happens is that one of the things that we noted in here is notice that there's multiple technical reviewers on here. Sign for it. The idea here is that sometimes not a single technical reviewer can answer all these questions. They don't have the knowledge to be able to do all that. So the answer to that is that what you would try to do is that we need to have at least one technical review sheet completely filled out. So let's say that Jennifer Smith, she knows the answers to 22, 23, and 26. I didn't know the answers to those. So what happened was she'd go through and say, okay, I'm answering for 22, 23, and 26 and signing it off. This way we make sure that we have everything accounted for. Many, many years ago, one of the things I found out was it was too easy for people to just say, I really don't know the answer to that, so I'm going to say NA. And that doesn't work with that. You know what I mean? So what happens is that if there's something that's NA, usually in this thing, in the reviewer comment area, if you look at the actual instructions, it actually says that you have to explain why it's NA. You just can't mark NA. You got to explain why it's NA. Right? This sheet is an example of an engineering verification. So it's kind of funny in a way because you would think, okay, technically, wouldn't you think engineering would be involved with that? And in some cases, they're combined. In some cases, they're combined. And this company, what they decided to do was actually make a separate document for engineering. Whereas in this engineering document, what they did here is that they really get into like the design of the equipment, making sure that it's within the pressures and temperatures and volumes and all those different things. So this engineering one is just a little bit different focus, and it's more on the design attributes and stuff, making sure that the equipment is being operated within its design parameters. Whereas the technical side is looking more generically at the technical side, right? So I wanted to share this with you to show you that, hey, sometimes they will give you an engineering verification, right? Okay. And then this was just the last page of the engineering document, right? So that is, so notice in here that these sheets, these review checklists can be very thorough, or you can make them as thorough as that, that works for you, right? Again, no one's trying to make you nuclear. I'm not even trying that. I wouldn't wish that on my worst friend there to be able to do that. Still the same. There's a lot going for the nukes in this area with it. They have a lot at stake, but I'll tell you, from my experience with the refiners and petrochem, even though I'm still fairly new at that over the last few years, they could definitely gain from a little bit more rigor here to be able to do that, right? Now, the other side of this is called validation, right? Now, a user or team of users performs a validation of the following procedure alterations. Anytime that you have a new procedure, a technical procedure that's going through extensive change or revision, or if you have a procedure that's also is used to support the actions necessary in an emergency procedure, or maybe an abnormal operating procedure, right? And so that SOP has some type of tie with those documents. They need to be validated, right? So now, what does that really mean? Well, typical validation methods include performance on a mock-up or spare equipment, simulator scenario, walkthroughs, comparisons, tabletop reviews, bench tests, maybe in the labs, whatever else. All these things are considered the methods that you can do for a validation, right? Now, a strong industry best practice is also to use a validation reviewer checklist, right? To be able to do that. Now, the following checklist questions are provided to aid reviewers in the performing procedure validations in a more consistent manner, right? The checklist questions are not all inclusive of those questions that may be appropriate depending on the extent of the procedure change, right? Only those questions that are applicable based on the extent of procedure change are necessary to be completed with NA selected for those things that are outside of scope, right? So now if you look at this, so now notice the difference between the verification and validation questions, right? So Validation. Are new or revised steps or sections, can they be performed out of sequence identified? So if something can be done out of sequence is identified, right? Can the new or revised steps be performed in a sequence written? Are specific limits provided for parameters that need to be controlled, you know? Are the units as they appear on the instruments used to obtain the data? Do reference steps return the user to the correct step? You know? Do steps return the equipment to the original or desired condition? Are trip sensitive steps, you know, clearly identified, right? Are equipment, control, or switches, panel nomenclature, part numbers consistent with attachments, drawings, and actual equipment labels, right? Are component physical locations accurate and descriptive, you know? Are the words and symbols used familiar with the users, right? So if you look at it, this is a much more focus on the user with the document in the field than it is for doing the technical verification.